Let us continue condensation polymerization. Now we are taking a condensation polymerization. This condensation polymerization is also called step growth polymerization. Step growth polymerization. Condensation polymerization is also called step growth polymerization. Okay. Here, what is initiator in the sense cation or anion? Therefore, intermediate is cation or anion in this mechanism. Okay. Now we will see. First one we will take nylon 66. How to prepare nylon 66? That we will see. Now, to prepare nylon 66, we are taking what in the sense adipic acid. We are taking. We will take adipic acid. Adipic acid formula is HOOC, CH2, 4 times COOH. This is called what in the sense adipic acid. This adipic acid. Then we will take hexamethylene diamine. Hexamethylene diamine will take. We are taking a hexamethylene diamine. We are taking hexamethylene diamine. Now, what is the temperature we are providing in the sense 553 Kelvin we are providing. 553 Kelvin we are providing. Then high pressure we are providing. We are providing high pressure. So now what we are getting in the sense nylon 66 we will get. That means this OH group, this H will go away as water. So what is the remaining in the sense here? CH2 4 times this CO group. Here what is there means NH group is there. Here CH2 6 times is there. CH2 6 times is there. Here hydrogen is going out as eliminating out as water. Therefore, what is the remaining in the sense NH is the remaining. Here in this COH, this OH is eliminating out as water. Therefore, what is the remaining in the sense CO? So it continues like this. Okay, this is called what in the sense nylon 66. This is only nylon 66 because this 6 is nothing but adipic acid is having 6 carbons. This 6 is nothing but hexamethylene diamine is having 6 carbons. Okay, then this is polyamide. This we can say polyamide we can say because here functional group is what means amide. CONH. This amide is the functional group here. Therefore, it is polyamide. This name is nylon 66 we can say. Okay. What is the use of this nylon 66? This nylon 66 is used for making sheets. Bristles for brushes. Bristles for brushes. Bristles for brushes, and in textile industry. And in textile industry, it is used. It is used in textile industry and for brushes, bristles, and sheets. For making sheets, this nylon 66 is used. So, okay. Then we will see nylon 6. Nylon 6 preparation. It is one condensation polymer. It is one condensation polymer. How to prepare this? We will see. We are taking a caprolactam. We are taking caprolactam. Here double bond O. This is what in the sense caprolactam. This caprolactam is heated to 533 to 543 Kelvin. 533 to 543 Kelvin it is heated. And water molecule is there. Okay. Now what is happening in the sense here this ring is opening. That's all. This ring is opening. This ring is opening and we are getting what in the sense like this group. This C double bond O, CH2 5 times, then NH. This is repeated n times. This is called polyamide. This polyamide is nylon 6. This polyamide is nylon 6. So how it is repeating like this? That we will see. How it is repeating like this? That point we will see. This caprolactam NH. Here CO. Okay. Another caprolactam we will take. Another caprolactam we have taken. We will take one more caprolactam. One more caprolactam we have taken. Cell. Now we'll see this nitrogen is having lone pair. Nitrogen is having lone pair. We can say this nitrogen is attacking this carbon. Therefore, pi bond will shift. Again, it will come like this. Therefore, since this nitrogen is attacking, this bond is migrating this side. This bonding is migrating this side. Okay. Then this N is attacking here. This carbon. This bond is migrating towards like this. Then next N will attack this carbon. This bond will migrate like this. Okay. Therefore, what we are getting? You see that it is the here something is attacking. Here NH is attacking. That bond will write. This CO group I will write. This CO group. Here CH2 1, 2, 3, 4, 5. 5 CH2 I will write. 5 CH2. This is NH. That NH. This N is making bond with this CO. That CO. Here CH2 5 times. CH2 5 times. This NH. This NH. Then here this CO. Here CH2 5 times. CH2 5 times. This NH. Then this bond is cleaving means bonding with the neighbor CO. Okay, like this it continues. Therefore, only it is called what in the sense polyamide, because amide is the functional group. Amide, polyamide, we can say it is nylon 6 because it is from this nylon 6. Why? Because caprolactam is having 6 carbons. Therefore, nylon 6. Okay. It is used for what? Used for manufacture of tire cords. Manufacture of tire cords. Manufacture of tire cords. Then fabrics. Then fabrics. Then ropes. Then ropes. It is nylon 6 is used for manufacturing tire cords, fabrics, and ropes. Okay. Next we will see Dacron or Terylene. Dacron or Terylene. Dacron or Terylene. Dacron or Terylene we will see. Dacron or Terylene. Now we will take ethylene glycol. Now we will take ethylene glycol. We will take ethylene glycol. We will take. Then we will take terephthalic acid. Terephthalic acid. Terephthalic acid we will take. Terephthalic acid. Terephthalic acid. It is heated to 420 to 460 Kelvin. It is heated to 420 to 460 Kelvin. Then zinc acetate antimony trioxide catalyst. Zinc acetate antimony trioxide. Antimony trioxide. This mixture acts as catalyst. This mixture acts as catalyst. So what we will get, that we will see here. It is condensation polymerization. Therefore, elimination of water molecule here. Like this. This OH group and the neighboring is eliminating as water molecule. It is also eliminating as water molecule. So here what is the remaining in the sense here this oxygen, these two CH2 groups, this oxygen, this CO group, this phenyl ring, then this CO group. Okay, N types. So here what is the functional group? COO. Functional group is ester. Here this is a polymer, therefore polyester we can say. Here what is eliminating group in the sense water molecule is eliminating group. Okay. This polyester name is called Dacron or Terylene. So it is prepared from ethylene glycol and terephthalic acid. Okay. Then we'll see what is the use of this Decron or terylene. It is used as a crease resistant. Crease resistant. Crease resistant. Used in blending with cotton and wool. Used in blending. Blending means mixing. Blending with cotton. Blending with cotton and wool. Wool fibers. Wool fibers. Glass. Glass. Reinforcing materials. Glass reinforcing materials. Glass reinforcing materials. Reinforcing materials in safety helmets. In safety helmets. Okay, this Decron is used like this. Okay, next we will take phenol formaldehyde polymer. Phenol formaldehyde. Phenol formaldehyde polymer will take. Phenol formaldehyde polymer we are taking. Okay, here we are taking a, for this we are taking phenol. We are taking phenol, then we are taking formaldehyde. In the presence of acid or base, in the presence of acid or base, what we are getting in the sense, we are getting orthohydroxybenzyl alcohol. We are getting orthohydroxybenzyl alcohol. We are getting. Then, like this, it is a difunctional group. Like this, 2 times CH2H. One is at ortho position, and another one is at para position. This we will get. Next, we are getting this OH, phenyl ring, 3 CH2OH groups. One at ortho, one at para, another one at ortho. So like this we are getting. So when phenol is treated with formaldehyde, we are getting 3 types of compounds we are getting. So how we are getting these 3 compounds, that we will see. Now, when the medium is acid, how we will get this? Okay, first we will take formaldehyde. So medium is acid. Acid is attacking this lone pair. Okay, therefore we will get a HC double bond OH plus. We are getting like this. Then what happens means this pi bond is shifting to oxygen. Therefore we are getting carbon plus charge. Carbon plus charge we are getting. Okay, this carbon plus charge is attacking this phenol. This carbon plus charge is attacking the phenol. Okay, here 5 bonds we will write. This we will write. This HCOH, this positive charge. Here hydrogen. This pi bond is coming like this and attacking here. So we will get here OH will be there. Then here hydrogen, CH2OH, here positive charge. So it is going for resonance. Then if it is coming like this and H plus is removed, we are getting a OH. Here pi bonds will give. Here we will give a CH2H. CH2H will give. Okay. So this positive charge we have removed because this bond shifted as pi bond. This is removed as H plus. So when phenol is reacting with the formaldehyde in the presence of H plus, what electrophile is attacking means CH2OH is attacking. Therefore, we are getting so and so compound. If it is again attacking this para, you will get like this compound. Okay, if this electrophile is attacking this para position, you will get this compound. Okay, if this C plus is attacking this carbon, you will get this compound. Okay, if this C plus is attacking this carbon, you will get this compound. Sir, In the presence of acidic medium, we are getting like this. In the presence of basic medium, how we will get? What is the mechanism? That we will see. In the presence of basic medium. So phenol we will take. We are taking phenol. This oxygen is having 2 lone pairs. Now OH minus we will take. This oxygen is having 3 lone pairs. Okay. So now this OH minus is taking this H plus and becoming water. Therefore, this bond is shifting to oxygen. So water is leaving. So what we are getting in the sense, oxygen gets 3 lone pairs now and a negative charge. So we are given like this. Phenoxide we got. This phenoxide is attacking formaldehyde. This phenoxide, due to phenoxide, now formaldehyde is going for reaction. How it is going for reaction, that we will see. Here pi bonds will give, here hydrogen is there. Okay. Now this lone pair becomes pi bond. This pi bond comes as negative charge. This negative charge attacking this carbon. This bond goes to oxygen and becomes O minus. Therefore, we will get here double bond O. This will have 2 lone pairs. Here 2 pi bonds will be there. And here hydrogen. Here CH2O minus. CH2O minus. Correct? Sir. Next what happens means, next what happens, you see, this bond is shifting to this place. Therefore, it becomes H plus. This is shifting to this place, so it becomes O minus. This H plus goes to here, therefore it becomes OH. So OH. Here this 3 pi bonds, therefore ring. This is CH2O minus. CH2O minus. This O minus takes H plus from water. This O minus takes H plus from water. Therefore, we will get so and so. We have got so and so. Okay. So we got so and so. Therefore, we got this compound we got. In this way only, this compound and this compound we are getting. Sir. So when phenol is reacting with formaldehyde in the presence of acidic medium or basic medium, we are getting like these 3 compounds we are getting. Sir. Next we will see. Now this orthohydroxybenzyl alcohol will take. This orthohydroxybenzyl alcohol will take now. We are taking a orthohydroxybenzyl alcohol. Orthohydroxybenzyl alcohol will take. Orthohydroxybenzyl alcohol in the presence of basic medium. In the presence of basic medium, what we are getting? What we are getting in the sense, we are getting so and so compound. We are getting so and so compound. This compound is called Novolac. This compound is called Novolac. Sir, how we are getting this compound? We will see what is the mechanism involved in this one. What is the mechanism involved in this one, that we have to see. Okay. Now we will take this. This is a CH2OH is there. First, it takes a H plus from water. It takes a H plus from water. Okay. It takes H plus from water. That means water we will write. From this water, it takes H plus. So what is leaving in the sense, OH minus is leaving. So we will get this OH. This is a CH2 OH2 plus. CH2 OH2 plus. Okay. It takes H plus. It takes H plus from water. Then this bond is shifting and it is leaving as water. So we are getting a We are getting here CH2 plus. We got CH2 plus. Sir, this is attacking a next like this compound. Next like this compound. Here CH2H is there. Here pi bonds present like this. Here hydrogen is present. Now this pi bond is coming here. That is attacking this carbon. Okay. Therefore, we will get this OH. This CH2 is making bond with this carbon. Here this OH, CH2OH, here H, here pi bonds we will give. Pi bonds we have given like this, here positive charge. Then this bond is coming to this place, H plus is leaving. Therefore, we will get this OH, this phenyl ring, here CH2, here pi ring, here OH, here CH2OH. Okay. So we got one CH2 bridge, Next, what will happen means this OH will be removed as water. Then it becomes CH2 plus. This CH2 plus will attack this compound. Therefore, if it continues, you will get like this. It is called Novolak. This is called Novolak. Okay. Then next, in this one continuation, this Novolak we will take. To this what we are adding in the sense formaldehyde. In the presence of acidic medium or basic medium, it is warmed. What we are getting in the sense we are getting backlight. This is a infusible solid mass. We can say infusible solid mass. This backlight is infusible solid mass. How this backlight will be there? That we'll see. This backlight structure we'll see. This is OH. Here phenyl ring. Here CH2 group act as a bridge. Another phenyl ring. Here OH group. Here CH2 group act as a bridge. Another phenyl ring. OH group. Here CH2 group act as a bridge. It continues. Similarly, here CH2 group act as a bridge. It continues. It is one Novolak. Okay. It is one Novolak. Another Novolak we will take. It is a phenyl ring. Here OH group. OH group is there. Here a bridge is here. CH2 bridge is here at a meta position. So here CH2. Here phenyl ring. Here OH. Another CH2. Phenyl ring OH. Another CH2. What happens means between these two carbons, now between these two carbons CH2 linkage is coming. Between these two phenyl rings CH2 linkage comes. Okay. So CH2 linkage is there between these two carbons, like this is there. This is called what in the sense backlight, infusible solid mass. Fuse carrier, if you see in the houses from current electric current, we are getting domestic current. No, in that beginning place a fuse carrier will be there. That fuse carrier is made up of this backlight. It is infusible solid mass. It is what is the use of this backlight? You will see. It is used for making combs. Then phonograph records. Phonograph records. Electrical switches. Then handles of utensils. Etc. Sir, the use of backlight is so and so. Okay. Next, we will take a melamine formaldehyde polymer. Melamine formaldehyde polymer. We are taking melamine formaldehyde polymer will take. So, how to prepare this melamine formaldehyde polymer, that we'll see. Now we are taking the compound. This is N. Here N. Here N. So and so ring we will take. Here we will give the 5 bonds. Then here one NH2 group. Here one NH2 group. Here one NH2 group we will take. Okay, so and so compound we are taking. It is treated with what in the sense formaldehyde. It is treated with formaldehyde. What we are getting in the sense we are getting so and so compound. Here we will give NH2. Here we will give NH2. Here we will give NHCH2OH. Okay. Then it is converting into what in the sense N. Here N. Okay, we have given. Then we will give 5 bonds. Here 5 bond, here 5 bond, here 5 bond. Here we will give NH group. Here we will write NH group. Here we will write NHCH2 group. This is what means melamine polymer. It is what means melamine polymer. Okay. This melamine polymer is used for what? It is used for unbreakable crockery. It is used for unbreakable crockery. It is used for unbreakable crockery. Okay. Next we will see urea formaldehyde. Urea formaldehyde resin. Urea formaldehyde resin will take. Urea formaldehyde resin. We are taking urea formula NH2CO NH2. It is treated with formaldehyde. So we are getting a NH2CO NHCH2OH. Then what happens means from this OH group and NH2 group H leaving as water. Therefore, what compound we will get in the sense we are getting a polymer like this. We are getting a polymer like this. It is called a urea formaldehyde resin. It is called urea formaldehyde resin. So how to prepare urea formaldehyde resin we'll see. We'll take this compound here, NH2, this CO, this NH, CH2OH. Another compound I will take NH2, CO, NH, CH2OH. Now we will round off water. We will round off water here. So it is leaving as water. It is leaving as water. So what we will get? NHCO, NHCH2 single bond. This is called urea formaldehyde resin. So what is the use of this? It is used for making unbreakable cups. Unbreakable cups. Unbreakable cups. Then laminated sheets. Laminated sheets. Okay. Next we will go for a glyptol. Next polymer is glyptol. Okay. We will take ethylene glycol. We'll take ethylene glycol. Then phthalic acid will take. We'll take phthalic acid. phthalic acid. So here what happens means here like this water molecule is eliminating, then this is going for water molecule elimination, it is going for water molecule elimination, therefore we will get this oxygen CH2 CH2O, this CO group, then this CO group, then here phenyl ring, here phenyl ring. This name is called a glypta. This name is called glypta. What is the use of this? It is used for manufacturing. It is used for manufacturing paints and lacquers. Used for manufacturing paints and lacquers. Next we will see about copolymerization. Next we are seeing about copolymerization. So, copolymerization can be made by chain growth polymerization or step growth polymerization. This copolymerization we will do by chain growth polymerization or step growth polymerization. That means initiator can be free radical, otherwise initiator can be cation or anion. So, for this we will take one example. We will take 1,3-butadiene. We will take 1,3-butadiene we are taking. It is treated with what in the sense of styrene. It is treated with a styrene. So what compound we are getting, that we will see. Here how the bond migration will be there, means this bond is migrating here, this bond coming in between this CH2 and CH, this bond is shifting like this. So from neighboring styrene bond will attack here. So here this CH2, before that bond is there, CH2, this double bond becomes single bond, this CH single bond becomes a double bond, CH, this double bond becomes single bond, then here single bond will be there, CH, this double bond becomes single bond, CH2, like this. Here what is there means phenyl ring is there. Phenyl ring is there. This is called what in the sense, it is butadiene, it is butadiene, it is styrene. Butadiene styrene. So we can say this is called butadiene styrene, butadiene styrene copolymer. Butadiene styrene copolymer we can say. Now, what is the use of this? It is used for manufacturing of auto tires, floor tiles, footwear components, cable insulation, etc. Okay. Next we will go for natural rubber. Next we will go for natural rubber. How to prepare natural rubber we will see. We will take isoprene. We are taking a isoprene, we will take. This isoprene goes for polymerization to give what in the sense natural rubber will be obtained. So that we will see. So how the bond migration will be there, that we will see. What happens means here we will take two groups, two times we will take this isoprene. Isoprene we will take two times. Isoprene we have taken two times. So how the bond migration is there? See, this bond is shifting to this place. This bond is coming in between this CH2 and this CH2. Then this bond is shifting to this place. This bond is shifting to this place. So from neighboring isoprene bond will come here. Okay. So first we will write this CH2. I will write that CH2. This double bond becomes single bond. This carbon is having CH3. That CH3 I have written. This single bond becomes a double bond, that I have written. This CH, this double bond becomes single bond. This CH2 I will write. Next, this CH2 I will write. Okay, this CC double bond I will write. CC double bond. This CH3 I am writing. that CH3, this carbon is having hydrogen, that hydrogen, this CH2 I will write. Okay, next neighboring isoprene I will take CH2, CH3, double bond CH, single bond CH2, single bond. Okay, this is a polymer. This polymer is called a natural rubber. In this polymer, what is there? I will see. In this polymer, what is a monomer in the sense isoprene? Isoprene is the monomer. It is present poly times, therefore polyisoprene. Here it is 1,4 addition, we can say. At this first carbon addition is coming, second, third, at fourth carbon addition is coming. Therefore, it is called 1,4 addition. So 1,4, 1,4 polyisoprene. Here this CC double bond. In this CC double bond, similar groups are on same side. Therefore, it is cis isomer. In this CC double bond also CH2 CH2 on same side. Therefore, it is cis. So we can say it is cis 1,4 polyisoprene. Cis 1,4 polyisoprene. It is called a natural rubber. What is the properties of this natural rubber? What is the uses of natural rubber? That we'll see. So natural rubber, intermolecular force. Intermolecular force between chains is van der Waals force. In the natural rubber, intermolecular force between polyisoprene chains is van der Waals force. This natural rubber will present like a coiled structure. Coiled structure. This can be stretched like a spring. It can be, this natural rubber can be stretched like a spring. Therefore, it is having elastic character. It is having elastic property. This natural rubber will become soft at high temperature, soft at high temperature of temperature greater than 335 Kelvin. Soft at high temperature. Then it is brittle at low temperature. It becomes brittle. It becomes brittle at low temperature. The temperature is what in the sense less than 283 Kelvin. Then it is having high water absorption capacity. This natural rubber has a high water absorption capacity. High water absorption capacity. High water absorption capacity. Okay. This natural rubber is soluble in non-polar solvents. It is soluble in non-polar solvents. Non-polar solvents. Then it is attacked by oxidizing agents. Natural rubber is attacked by oxidizing agents. Oxidizing agents. Natural rubber is attacked by oxidizing agents. Like this you can say. Next we will go for vulcanized rubber. Next we are taking vulcanized rubber. Vulcanized rubber in the sense, what in the sense? Natural rubber will have sulfur cross linkings. That is called vulcanized rubber we can take. We can say. Sir. So now we will take a rubber we will take. We are taking natural rubber, we are taking. To this we are adding sulfur and we are adding additives, and it is heated to 373 to 415 Kelvin. 415 Kelvin. 373 to 415 Kelvin. We are getting what in the sense? Vulcanized rubber. We are getting a vulcanized rubber. Okay. This rubber gets stiff due to sulfur crosslinks. Due to sulfur crosslinks, it has a stiffness. This vulcanized rubber has a stiffness due to sulfur crosslinks, we can say. Sir. So how that sulfur crosslinks will be there in the vulcanized rubber, that we'll see. How the sulfur crosslinks will be there. Now we will take natural rubber in the sense CH2, CH3, here double bond CH, CH2, like this continuation. Natural rubber polymeric chain like this. Another polymeric chain of natural rubber will take. Another polymeric chain of natural rubber we have taken like this. It is continuing like this. Okay. So again we'll take here CH, CH3, double bond CH, CH2. It is a polyisoprene chain. Another polyisoprene chain we will take. Another polyisoprene chain we have taken like this. Here instead of that CH3 we have given H here, that we will make it as CH3 here. So here CH3. Okay. Now what we